Welcome to Culture, Worldview, and Origins. We're Tim and Holly Nyquist. We're in the chapter 13, session number 6, about Kuhn's critical thinking applied to science. This chapter, chapter 6, is called The Anomaly and the Emergence of Scientific Discoveries. So we'll keep that in mind as we're going through the different quotes that we're highlighting, in that this chapter is about anomalies and the emergence of scientific discoveries. Normal science, the puzzle-solving activity we have just examined, is a highly cumulative enterprise, eminently successful in its aim, the steady extension of the scope and precision of scientific knowledge. So what he's talking about is that normal science is successful in its aim. It's cumulative, it builds, and it functions within a community. And that community is held together, cohesive by the paradigm that it subscribes to. Yet, one standard product of the scientific enterprise is missing. What's missing? Well, he says normal science does not aim at novelties of fact or theory, and when successful, finds none. Okay, so science is to be progressive, or is to solve problems going forward, but when normal science is practiced, there are no novelties, because a novelty would be something unexpected, something that couldn't be explained by that paradigm. So of course that would not be expected, because you expect that paradigm to explain everything. So there are no novelties, and there are no novelties that are looked for. One standard product of the scientific enterprise is missing. Normal science does not aim at novelties, because a novelty could create instability within the community and within that paradigm. New and unsuspected phenomena are, however, repeatedly uncovered by scientific research, and radical new theories have again and again been invented by scientists. History even suggests that the scientific enterprise has developed a uniquely powerful technique for producing surprises of this sort. Okay, so what we're looking at is that new and unsuspected phenomena are, however, repeatedly uncovered. And when they are uncovered, what happens to them? What do we do with them? Well, again, Stephen Jay Gould's quote of Theory, Habit, Prejudice, and Culture, he says that by our theory, our habit, prejudice, and culture, we select what we're going to look at and how we are to interpret it. So if there is something unsuspected, then it will be put off until there's an explanation for it. But usually it will not damage the paradigm. It will just be isolated until it can be explained. He goes on, this is what fundamental novelties of fact and theory do. Produced inadvertently by a game played under one set of rules, their assimilation requires the elaboration of another set. Okay, so he's saying this is what fundamental novelties of fact and theory do. Fundamental novelties. So we're talking about foundational issues. So we're not talking about superficial or just something that, well, that wasn't expected, but it doesn't really rock the boat. We're talking about foundational, fundamental novelties of fact and theory, produced inadvertently by a game played under one set of rules. Their assimilation requires the elaboration of another set. And elaborating another set is going to create a instability of the paradigm that is at that time being implemented. anomaly, and the emergence of scientific discoveries. The distinction between discovery and invention. Okay, that's interesting. Is that, are we discovering something or inventing something because of our paradigm, because of our worldview, or between fact and theory? Before we've seen fact and theory is that theory is a way of looking at something. Theorein, the Greek is spectator, so it's theory comes from the context of spectator, of watching, looking at something, and spectacles are what we look through to watch something. So a theory is what we look through to understand something. So he's saying that fact and theory are linked. In other words, because of our theories, we interpret data to be facts. Will, however, immediately prove to be exceedingly artificial. The distinction between discovery and invention, or between fact and theory, will, however, immediately prove to be exceedingly artificial. Its artificiality is an important clue to several of this essay's main theses. What he's saying is that the separation between discovery and invention is similar to the relationship of fact and theory. In other words, when we discover something, it's because we're equipped to and open to that discovery. Otherwise, we don't see it. It's not there. Discovery commences with the awareness of anomaly. In other words, we're aware of it. Yes, this does not fit the paradigm. But instead of setting aside, we continue studying it. With the recognition that nature, this is his way of, Kuhn's way of saying it, discovery commences with the awareness of anomaly, i.e., with the recognition that nature has somehow violated the paradigm, induced expectations that govern normal science. I don't think we can accuse nature of violating our paradigm, but I think we can assume that our paradigm is violating maybe what nature reflects, what nature is, which we can't change, but we have to adjust our paradigm to reflect what is there, what we understand nature to be reflecting. But if both observation and conceptualization concepts, fact and assimilation to theory, are inseparably linked in discovery, then discovery is a process and must take time. To discover something, we have to have the categories. We have to understand what it is that we're discovering and how it is different from what was discovered before. And so it will probably require a different set of rules, which means then to discover something requires a lot of antecedents of forming those categories, of open to another set of rules. So before we can make a discovery, there has to be a process put into place. That's why he says, then discovery is a process and must take time. It takes not only time, but it takes our openness to be open to the rules that need to be changed. Only when all the relevant conceptual categories are prepared in advance, in which case the phenomenon would not be of a new sort, can discovering that and discovering what occur effortlessly together are and in an instant. So in other words, to discover something, we have to already have the relevant conceptual categories to discover it, to see it. Prepare in advance, in which case the phenomena would not be a new sort. It's something we're prepared for. It's something that we've maybe seen before, and we're preparing now to see it because, or to discover it because it's different, because it didn't fit the rules. So now I'm going to change some rules and see what happens. Grant now that discovery involves an extended, though not necessarily long, process of conceptual assimilation, conceptual change, of changing our concepts of what's out there. Can we also say that it involves a change in paradigm? Depends on how big of a conceptual change we're talking about. In that we know that there's overarching paradigms. We know that there's individual paradigms for each subdiscipline of science within that. So what we're talking about is a change of paradigm would be, there would be a conceptual change. There would need to be a change of paradigm to change the rules, to change the view, to be able to see. So the answer to that would be yes, it does involve a paradigm change, but maybe at a different level. Now he's going into an example of the discovery of the element oxygen. What the work on oxygen did was to give much additional form and structure to Lavoisier's earlier sense that something was wrong, something was amiss. So he was studying oxygen, or he was studying something, and it produced something that was amiss. It didn't fit the box. So he starts working on the box. It told him a thing he was already prepared to discover: the nature of the substance that combustion removes from the atmosphere. So he was studying, what does combustion remove from the atmosphere? And different scientists had different theories about what it removed. He opens the box. He takes the box apart and starts changing it because he was aware of something that was wrong. That advanced awareness of difficulties must be a significant part of what enabled Lavoisier to see in experiments like Priestley's. Okay, Priestley was another scientist that was experimenting on the same processes of combustion. But Priestley maintained a certain box, a paradigm of that time, where Lavoisier changed the paradigm, changed his box or amplified it. And so this is saying that what a significant part of what enabled Lavoisier to see in experiments like Priestley's a gas that Priestley had been unable to see there himself. Priestley, because of his paradigm, because of his worldview, did not see what others saw in his own experiment. Conversely, the fact that a major paradigm revision was needed to see what Lavoisier saw must be the principal reason why Priestley was, to the end of his long life, unable to see it. So Priestley never saw what Lavoisier saw because he went and stayed with a certain box, certain paradigm. And he would not change. Whereas Lavoisier says, something's wrong, something's amiss here, something's going on. The box needs to be changed. And after changing the box, he saw something different. Something that Priestley never saw because he never to the end of his long life, was unable to see it because he never changed his conceptual paradigm. Paradigm procedures and applications are as necessary to science as paradigm laws and theories, and they have the same effects. So paradigm procedures are defined by the paradigm. But not only procedures and applications, but theories are also defined. They have the same effects. Inevitably, they restrict the phenomenological field accessible for scientific investigation at any time. The box, the paradigm, restricts what we can see. Even though what we see may not be what's there completely, we can't see what's there if our box limits our vision. So this is what Kuhn is going at, is that Priestley never saw what Lavoisier saw because they had different paradigms. They adopted different paradigms. They saw different things. We're looking at anomaly and the emergence of scientific discoveries. How do they emerge? They emerge by being open to a change of parameters, change of paradigms. Much has been said so far suggests that discoveries predicted by theory in advance are parts of normal science and result in no new sort of fact. Okay, so if it's predicted by my box, then I'm not going to discover anything new, because to discover something new is to look outside the box. So parts of normal science result in no new sort of fact or discovery. Often, however, that discovery is not quite the one anticipated by the speculative and tentative hypothesis. Only as experiment and tentative theory are together articulated to a match does the discovery emerge and the theory become a paradigm. So he's saying here that theory and fact and practice have to come together. And when they come together, then discovery will be made. And discovery is like scales coming off of the eyes. It's always been there, but they didn't see it. Without the special apparatus, each box, each paradigm has its apparatuses, and it gives instructions of how to build them. Without the special apparatus is from outside the box, that is constructed mainly for anticipated functions, the result that lead ultimately to novelty could not occur. So if we make an apparatus according to the instructions of the box, then we will not discover novelty. Novelty will not occur, and we will not discover anything new. And even when the approaches exists, novelty ordinarily emerges only for the man who, knowing with precision what he should expect, is able to recognize that something has gone wrong. Anomaly appears only against the background provided by the paradigm. So you keep the paradigm, but you open the box to be open to something else that might be out there. So you make the concepts, you flex the rules, and then you are able to discover what has always been there. By ensuring that the paradigm will not be too easily surrendered, resistance guarantees that scientists will not be lightly distracted, and that the anomalies that lead to paradigm change will penetrate existing knowledge to the core. So if there is a change, if there is a paradigm change, that paradigm will affect knowledge to the core. and it may reconstitute the knowledge. It may take that knowledge and reform it into knowledge that is reliable knowledge that would be produced by the new paradigm. This is session number 6, wrapping up 6.